Mic check, 1 2 1 2. Alrighty. Let's see here. Gonna do a unit 4 review with y'all, and I'm sure y'all will appreciate it. But hopefully we won't take too long with this, because I'm tired, you're tired, we're all tired. I'm gonna pull up the chat box. So hopefully, if you guys are online, knowing you probably still are, you guys can jump in on this stream, you know, receive those notifications, all that fun jazz. And yeah, let's see if we can get more people online. And my phone's frozen. Yay. Oh well. So you guys know the drill. As long as you send me a message and ask me to work on a question, I can help you, and we'll just go from there. Guess I'll type it in the chat box as well. Send me more questions. Yeah. Number 18. Yes, I got a viewer. All right. 18. We got a proof. Sweet. All right. You ready, Abby? Heck yeah, you are. So check this out. Got to look at our givens, and we got to identify, hey, what the heck do these mean? Well, that symbol right there, Abby, is telling you perpendicular, which means you're going to form a right angle. So I'm going to look at line DA and AB. That's this line here with this line here. And the perpendicular means you create a right angle. Boom. Now if I look back at the next one, now it's saying BC and DC. So that is what's going on here. So we got this line there and this line there. Those two lines meet and form again a right angle. Yes. Okay, that's 2 givens down. Last one to go. AB is congruent to DC. Now those are segments. So that means that those 2 segments are going to be marked with the tick mark. So right away we're going to write all our given. And actually, for the sake of time, I'll leave that to you to write down. I'm not going to write it down. Okay? But you better put that there. So now step 2, what I'm going to want to do is look in my picture and say, hey, is there any inherent information I can mark? And hopefully, Abby, you saw that we have the reflexive line. What's up, 21 Pilots Lover? We've got DB, this beautiful line going across. So we know that it equals itself. So we're going to give that a double tick. So we're now going to write down that DB is congruent to DB. Now if you want to write BD, that works too. Either way, it's correct. And we're going to write out reflexive property. Now this next step might be a little confusing because you're looking at the picture and you're thinking, well, Mr. T, this is an angle side side, and that spells a bad word, so we can't use it. But remember that I've told you guys before that if you're dealing with a right triangle, which is exactly what we have here and here, we're going to want to check and see if HL works. And in this case, if I separate the triangles and look at each part, here's a leg and here's a hypotenuse. And likewise on the other triangle, I have both corresponding parts. So remember that for an HL, you need to have 3 conditions. You need to have a leg marking, which was given to us. We need the hypotenuse marking, which was our inherent information, so that's the reflexive side. And then the last thing we need to establish is we have a right triangle. But remember that in order to establish a right triangle, you first need a right angle. So that's what we're going to do. We're going to say for step 3 that angle A, which is this corner here, and angle C are both right angles. So step 3, angle A and angle C are right angles. Now, there are some proofs where you do need to establish that the angles are congruent, but not for HL. For any of the other ones, angle side angle, angle side, if you have a right angle and it satisfies any of those, you're going to want to say, hey, these angles are congruent after you've established their right angles. But thankfully in this one, we don't need to. Now the reason they're right angles, if we look back in our given, we weren't given any words, but these symbols stand for a word, right? They stand for perpendicular. I don't know why I started doing that, but we're going to write definition of perpendicular. And in this case, we're going to say definition of perpendicular lines. Okay. Now that we've established we have perpendicular lines, now we can say that the triangles are right triangles. Now, you can write the letters of your triangles in any order as long as you have the order of the markings match up. Just look at your proof. This one is literally telling you that the triangle order. So I'm just going to copy that down and say triangle DAB and triangle BCD are right triangles. And why is that? Well, that's literally the definition of a right triangle, when you have exactly one right angle. Okay, so let's go through our checklist. We've established in our given the leg, we have the hypotenuse marked, and we have the right triangle. We have all three conditions satisfied for HL. So our last step is exactly our proof statement. Triangle DAB is congruent to triangle BCD. And why? Well, we kind of established that. Hypotenuse leg. All right. Hopefully that was helpful to you, Abby. Hopefully I wasn't rushing too much. You can, of course, come in and bug me tomorrow morning. Knowing my luck, I'll have probably 9 or 10 kids. Who knows? All right. Anybody else got any questions? By the way, guys, my girlfriend is here bugging me. Hold on. That little critter.
I said y'all should work on number 11.
She claims we should work on number 11, but I don't want to do number 11 yet. What's up, Dante?
I don't even know what number 11 is.
Exactly. That's my point. Get away. Weirdo. Oh, Dante asked for 11. I think he's doing that just to spite me. Dante, I hope you were actually asking for this. Okay, you get away. I'm going to get rid of you. Okay, just do it. Okay. Whatever, Dante. So check this out. We have that DF is parallel to GE. Okay, so parallel lines means they're parallel. Wow, that was dumb. We're going to mark them with arrows. Totally what I meant to say. Now, the other part of that given says DF is congruent to GE. So not only am I going to put those parallel line markings, I'm also going to mark them as congruent. So right now I've got, you know, these parallel lines and I have the congruent lines. Well, one thing I know I can mark right away is, again, the reflexive side, that middle line. Now, that middle line is going to help us out again, because if you remember, whenever I tell you there are parallel lines, we got to draw in our Z, or our letter N, however you see it, right? This tells us which angles are going to be the alternate interior angles, and they're going to be the inside angles to your letter. So right here, if I just start kind of going around the figure, then I have a side, angle, side. And likewise on the bottom triangle, I have another side, angle, side. Since the markings match in both triangles, we can say that the triangles are congruent by side, angle, side. So there you go, Dante. Side, angle, side. Just do it. Make your dreams come true. Hopefully you guys are having a good evening. Hopefully not freaking out about your test. You're welcome, buddy. What else? You know, it's funny because Parker, can you do a proof? I literally just did a proof, and he is fine. Why don't you pick a number, Dante? I already did number 18. Do 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 do. 22 is your request. Here we go. 22. Ooh, part of my thing got cut off. I'm pretty sure that's a letter Q. Alright, cool. So check this out. Parker wants number 6. Okay, I'll come back to that one. So 22, Dante. I look at this sentence here. It's telling me QR is bisecting this angle. So right away, I know that this line is splitting that angle into 2 equal parts. Dante, leave Parker alone. So eventually I'm going to need to write this statement into my proof. And then, of course, the next part, P, angle P is congruent to angle S. So I'm going to give that a double tick because that is a different angle, different measurement, hopefully. And so, step 2, I might want to write and say, okay, since that line is bisecting the angle, I can say angle PQR is congruent to angle SQR. Behave, children, or I'll stop this live stream. I sound like a father. This is bad. And this is going to be a definition of an angle bisector. Now, there's one other thing we haven't talked about at all, and that's the reflexive line. Okay, you're funny. All right, so anyways, back to this. We got to go back to our reflexive side. So that's going to be QR. No, you don't understand, Kayla. This student was like, I don't even have him, but everyone told me I should follow this live stream.
I was laughing at
Oh, whatever. I thought you were laughing at me. Anyways, jeez, everyone, calm down. QR is congruent to QR. Why is that? The reflexive property. All right. So let's see here. We've marked the angle. We've marked the side. We were already given the other angle. I believe we have all the information we need. We have an angle, angle, side, angle, angle, side. Now, some of you might be tempted to say, Mr. T, this is an SAA. No, we're going to read it as angle side side. So now we can, wait a second, look at your proof. What are we proving? We're proving that the segments are congruent, not the triangles. However, we need to establish that the triangles are congruent before we could do this. And this is going to lead us to our beautiful acronym CPCTC. Can Philip cut the chicken? Can Priscilla cook the chicken? Can Phil Collins tell something? I don't remember. Someone made up a good one, but yeah, Phil Collins, he's my boy. So then for step 4, and again, just kind of follow your triangle. Triangle PQR is congruent to triangle SQR. And again, we've established why. This is our angle side. And then last but not least, we have our PQ is congruent to SQ. And why is that? I can write CPCTC. There you go, Dante. There's your beautifully worked out proof. Parker, we're going to jump right to number 6, per your request. And I know McKenna wanted to look at that one as well. Right? I think McKenna said that. No. Janine. The last name threw me off, that's why. Okay. So, right here, you got your vertical angle, which is again one of our other, inherent informations that we're allowed to mark anytime. And so right here, I'm going to look at this and say, look, I have a side and 2 angles. And again, 2 angles and a side. Notice that the side marking is not between those angles. So this is our infamous angle side. Now, if we look at the order of our letters, A, B, E, I'm going from no angle marking to a double marking to a single marking. So with that regards, I've got to go in the same direction. So I start with no angle marking, double angle marking, single angle marking. And please don't forget the triangle symbol. Free point right there. Triangle C, B, D. And why is that? The angle side. So hopefully that helped you out, Parker. Keep the questions rolling, peeps. Otherwise, I'm just going to go right back to working on my paper. What was that? There's miso soup, there's udon. Okay. All right. What else, children? What else? Bring me your questions. Parker says she wants miso. I'm going to have to learn how to make miso soup then, Parker. All right, AJ, we're going to go to number 23, per your request. Okay, so real quick, AJ, before we start, look at your proof. What are you trying to prove? You're trying to prove that angle 1 is congruent to angle 2. So this is going to tell you 2 things. One, it's going to tell you that your final step is going to end in a CPCTC. But the second thing that it's going to tell you is going to tell you don't mark those angles. And here's why. If we're trying to prove they're congruent, we can't state they're congruent. That's kind of counterintuitive. It's like saying I'm a football player if you've never even played football. It just doesn't make sense. You have to prove that you're able to, do whatever sport, or say I'm a soccer player and you've never played soccer. Okay, so let's look at our givens. Angle L is congruent to angle N. So that's this corner here and this corner here. Check. LN is perpendicular to OM. So if I look at LN and OM, that's these two lines. Now, a common mistake that a lot of students tend to make is that you see that and you think, oh, we're going to mark these two sides congruent. You can't do that. And the reason that is you did not see the word bisector, or that M is the midpoint, or even perpendicular bisector. Okay, we only have that the lines are perpendicular, which means they are going to form right angles. Now, you only really need a right angle in one spot, because then it's implied it's in the other. If you decide, you know what, I'm going to put it on both, that's fine. Totally fine. Now, if we look at this proof, right now I have two angles. So this is already hinting to me that I need to use that right angle and say that those two angles are congruent. Because in a hypotenuse leg, we state that the triangles are right triangles. But that's only if we have a side marking that's a leg with a side marking that's a hypotenuse. In this case, I have two angles, which is not required in a hypotenuse leg. So right here for step 2, we're going to then say that angle LMO, or you could say OML, and angle NMO are right angles. They're right angles by the definition of perpendicular. But specifically, we're saying the definition of perpendicular lines. So then step 3, now I'm going to claim that those two angles are congruent. And why are they congruent? Well, if you remember me talking a lot about my boy Euclid, one of his postulates is that all right angles are the same. They all equal each other. So again, we're going to say definition of a right angle. Okay, so we've got our angle marking. We were given the other angle marking. We're just missing one more thing. Ah, hey, look at that. We're still missing our reflexive side. This beautiful piece right there. Boom. So now we're going to say OM is congruent to OM. And that is our reflexive side. The difference between the different bisectors. I'll get back to that, Parker, and I'll actually draw something that I made for one of my students that I tutored, and hopefully it'll help you. Well, I don't know why I said definition. I meant to say reflexive property. Okay. So then going back, now we have our side marking. So this is an angle side. So we're going to say the triangles are congruent before we can get to the CP/CTC. What does that mean? You're going to have to elaborate on your question, EO, because I don't understand what does what mean. Okay, so then here we're going to say triangle, let's say LOM. Triangle. And I mean, if you want to use LMO, you can do that too. But, you know, whatever, you know, as long as you keep the right order. So let's say LOM is congruent to triangle, that's a triangle, NOM, num. And that is our angle side. I'm going to minimize my work a little bit. And then our last step is our beautiful CP/CTC. angle 1 is congruent to angle 2, CP, CTC. Okay, so real quick, Parker, I'm going to answer your question for the different bisectors. Realistically, there's only one bisector, but I'm going to try to draw out kind of like a flow chart to kind of help you tell the difference. And then Eob will jump back to 21. And then hopefully that'll help you. So real quick, think of this as like a family tree. And I know this is going to sound weird, but let's just say you have perpendicular, okay? So things that are perpendicular, you can only have one thing perpendicular, and those are lines. So anytime two lines meet, they always create a right angle. And again, if you want to, you can put them on both sides. And it doesn't matter if the lines form a T or if the lines form like an L. Okay? Perpendicular just means right angle, nothing else. Okay? And in the house of bisectors, you have two types of bisectors. You have what are called segment bisectors, in which you have lines that cut other lines in half. So for instance, if I have something like this, so then that could create two equal sides, or in some cases when we've had the lines crossing each other, you can also have them either cutting one part or sometimes both parts. Depends on the wording. The other type of bisector you have is an angle bisector. So again, just kind of remembering, hey, you have this line and it's cutting this angle. So that would be, oh, this angle is now equal to this angle. You have two equal parts. Okay, so those are the two families. Now, if I decide to say, hey, I want to make a perpendicular bisector, they would form one unique picture. So the perpendicular bisector, I can spell, would look like this. It would be your T intersection. That's the only time it can happen. And that's when you have both a right angle and the tick marks on both sides. This is the only time you will have both. Now, if you're told you have a perpendicular bisector, you technically can, in one step, write like angle ABD and angle ABC are both right angles. Right? You could technically do that along with the two segments are congruent, because that is the definition of a perpendicular bisector. It does both at the same time. So, you know, again, this is just kind of like what the overall picture is. Perpendicular, you only have right angles. Bisectors, you only have the two equal markings. But again, you could have segment bisectors or angle bisectors. When you decide, hey, I'm going to combine them both, you only have one image, only one thing that could happen. All right? So, hopefully that helped you out, Parker. Dark shadow. What is good? Probably sleep. Sleep is probably good. Yeah. So, Eob, to number 21, hopefully this will help you. Oh, hey, look at that. We're going to go right to what I just talked about. MN is bisecting JK. Now, to be clear, MN is not getting cut in half, only JK is getting cut in half. So only this line is going to receive those tick markings. Okay? That's our step that we're going to write after our given. So then right here we're going to write JS is congruent to KS. And that is, again, our definition of a segment bisector. Okay. Now the next part of our given is that angle M is congruent to angle N. So let us mark those. M is congruent to N. Now, I don't have anything in my given talking to me about parallel lines. So I don't need to make any additional markings. So then what I'm going to do is then look at my picture and say, what am I missing? Well, I didn't mark my reflexive side. And by reflexive side, I meant my vertical angles. Tired, guys. So again, that vertical angle is different from the one that was given to us. So I'm giving that a double marking. Okay. So right here, looking at our drawing, we have two angles with a non-included side. Two angles with a non-included side. This one's a little interesting because it's like the second triangle flipped upside down from the first. So part of this, again, just following the markings, making sure that we know, hey, this is still the correct order, it's just flipped. So let's write our vertical angles. Again, use the markings to help you. I'm going to start using with the no marking, double, single. So by that token, I'm going to go no marking, double, single. And yes, I can do number 14 in a bit. Okay, so then number 3, my vertical angles, angle JSM is congruent to angle KSN. Now you have a choice. You can say vertical angle theorem, or you can say vertical angles are congruent. Okay. So then our last step, we have enough information to say, hey, the triangles are now congruent. So triangle MSJ is congruent to triangle NSK. Why is that? Because our angle side. Okay. Eob, hopefully that helped you out a bit. We'll go to number 14. Okay. Yes, NJ is bisecting LNK. So in terms of bisecting, again, I try to teach you guys, use objects to kind of help you remember these. In this case, I pretend that, you know, the yellow line is like my knife and it's cutting the bread. And I was going the wrong way. Here we go, LNK. So that first part, I'm going to be marking these two angles as congruent. Your dad was a little confused on your answers for 4 and 5. Well, I don't know what your answers are, Eob, so we could look at 4 and 5. Then, right here, LJK. Right here. So now I'm looking at this other angle, and so now that corner here and this corner are now split into 2 equal parts. So then we're done with the givens. Now I just look for any markings that I know I'm allowed to make. No assumptions made. These are inherent information. And lo and behold, we have the reflexive side again. So going back to our list, we have our angle, side angle, which is definitely one of them. Okay, so I'll take a look at those, Eob. Cali Coffee. Yeah. So there we go. Number 14. So numbers 4 and 5. Let's see here. So for this one, if you remember, Eob, we have our parallel lines, so that's our Z. So we're going to draw in our angle markings there and there, where the two lines intersect. And then we're going to draw in our reflexive side. Now, Eob, I don't have to tell you 500 times, hopefully, that this is a bad word. Yes, I am wearing a mic right here. Okay, so angle side side. That's not one of our 5. Spells a bad word. That's why it's going to be none. Now in number 5, I actually have 2 different answers I could do. There are 2 ways of looking at this. Preferably, I would rather you use one way than the other, but, you know, there's a little room for flexibility here. So again, drawing my markings to show, hey, these lines are parallel, and then drawing one of my lines for my Z, I can show, hey, this angle is congruent to this angle. Now, if I stop using my Z's here, I can then use my vertical angles, and I could say, oh, look, this is an angle, angle, side. Here, angle, angle, side. So one option is doing angle, angle, side, and again, it doesn't matter which one you do, you're going to be doing this order. Triangle, well, let's see here, MSJ, I go no marking, double single. So I have to go the same way, no marking, double single. So that's NSK. Now, the other way, if I ignore the vertical angles and decide, hey, I want to use the other Z, and here's what I mean by the other Z. My other Z, remember that I could draw a transversal this way, or I can draw a transversal this way. Both lines are touching the parallel line, so that means that I also have this angle that is an alternate interior angle. So now if I follow these markings instead, I have an angle, side, angle. So for this one, you could say angle, angle, side, or angle, side, angle. Now, here's where I have the preference. My preference is ignore the second alternate interior angle, use the vertical angle, and here's why. In a proof, we want to do this in the fewest amount of steps possible, as well as doing the least amount of work. Okay? The vertical angle is always a guaranteed angle that you can use. You don't have to guess, hey, which of these 2 angles are going to be congruent. Because knowing my luck, when I start grading these, and these will take me a while to grade because I'm checking all your letters and their order, some of you might say that angle J is congruent to angle N instead. For whatever reason, someone will. It just happens. Okay? Drawing the letter Z helps you determine which 2 angles are congruent. Okay, the vertical angles are just easy. They're right there. You don't have to do any extra work for them. They're basically a gimme. They're a freebie. So hopefully that helped you out, Eob. Yes, Abby, you do have to take the test tomorrow. Also, you guys should have your grades updated. I did input the extra credits from our review game, so hopefully that actually did help some of you guys out. So we should be good.
I believe in you guys.
See, my girlfriend believes in you. I believe in you. I believe that you can win. We answered quite a few. A lot of proofs. Almost all the proofs. Do we have any other questions, my little critters? I'm going to go back to that one thing that I was helping Parker with, because I know this might be useful for some of you. Alright, well, if, and only if, there are no other questions, I'm going to call it a night because I am exhausted. I've been working all weekend, including today on my paper, which is due Wednesday. Yeah. I feel you guys, trust me. Trust me when I say I'm stressed out, but I'm also telling you guys, you can't give up. Okay, you gotta keep fighting. I believe in you all. You're all great kids. I'm so lucky as a teacher to have you as my students. And I hope that this video helped you. Let me know if you guys need help tomorrow morning. I'll try to give like maybe 10-15 minutes in the beginning of each period to answer some questions, but I need you guys to, you know, be ready to go. I don't want to waste time getting you all organized. All right? Take care. Have a good night. I'll see you all tomorrow. Bye.